So far, we have analyzed sounds in terms of frequencies. This type of analysis, called frequency domain analysis, is very helpful to analyze them. But there's another way to analyze sounds that is important to understand for the purposes of mixing, which is in terms of their waveforms. This type of waveform-based analysis is called time domain analysis. Time domain analysis essentially means looking at a sound not in terms of the sine wave that makes it up, but in terms of the patterns of disturbances that it causes in whatever medium it is traveling through. That could be air, a human eardrum, a speaker cone, or the electrical signal of an audio cable. The intensity of disturbances that the sound causes at any given instant is called its amplitude. The sound of a sound is determined by its patterns of changing amplitude, its waveform, in other words. When you combine two sounds together, like playing them simultaneously through the same medium, their time domain disturbances are added together. The instantaneous amplitude of the resulting sound at any given time is a single mathematical sum of the instantaneous amplitudes of the separate sounds. This is why the final stage of mixing, when you combine the separate mixer tracks into one master track, is something called summing. It literally is just a matter of taking the sum of everything. It's important to understand that any sound can be analyzed both in the frequency domain and the time domain. You can look at a sound as a collection of sine waves, or you can look at it as a pattern of disturbances in a medium. Both perspectives are useful for different things.